Before starting this video, I want to let you guys know that Coding Cleverly also has a Patreon page. So go to patreon.com/codingcleverly and you'll see that there is a Patreon page that is available, and you guys could support the channel by just joining any one of these tiers. You guys also could become my patrons. That would also motivate me to provide better and better content. So all you gotta do is go to this page and show some love to Coding Cleverly. Enough with the shameless plug. Now let's go to the video. What's going on, guys? Today we're gonna be talking about queues. So queues, just like stacks, are a data structure, and we're gonna be implementing them using our linked list and node files. So first, over here you can see that the linked list and the node.java files are present. And after that, we also have a file named queue.java. Let's say a queue is like a line of people or a line of things. So whoever came first will get the thing first. First come, first serve. So that policy is adopted in queues. So we're just gonna copy it and paste. So suppose that these are students. So example here is that these are 5 kids and they're lining up to get their snacks from the snack bar. The lady over here who runs the snack bar, and she serves one student at a time. So once the first guy gets it done, it'll go out of the list, and then the next guy will come and will get his service. And from there, this will get his service once this one is done. So once this guy leaves, this will get its service. Once this guy leaves, the person behind him will get its service. And then once this guy leaves, the guy from here will get its service. So this is how the process goes. Yeah, it happens everywhere, day-to-day life. You could think of it as a line, a queue of people. Now, queues also support 3 main operations, just like stack. The enqueue adds data to the back of the queue. So this guy is enqueued at the end. So when you want to enqueue another one, you could just say there's another one over here. So enqueue happens in the end. Suppose there's one more person that wants to come, so he lines up at the end. He can't just cut his way to the front, so he'll have to wait in the line. And then after that, we have dequeue, which removes and provides data from the front of the queue. So if we want to dequeue this operation, like I said, once it gets its snack from the snack bar, it just goes out. So that's dequeuing it. So it's no longer in the list. And now this guy will be the next person there. And it will just return its value, whatever data it had contained. So whatever secret data it was provided, it will just return it to us. Awesome. That's what queues do. So the last operation is peek, and peek provides data on the front of the queue. So this operation is just gonna provide data for the front of the queue. This is the front, this is the back again, and you can just get the data from here. So these can be implemented using a linked list or array, and we're gonna be using a linked list for this case. I've done an array sample back in my video series in data structures and algorithms in C++. You guys could check that out in my channel. So we're going to use linked list to create our cool looking queue. Bounded queues have a limited size. Suppose that this is a bounded queue and the maximum size that it could support is 5. So enqueuing onto a full queue causes a queue overflow. Just like in a stack, it causes a stack overflow. If you add one more thing here, and if it's bounded, like suppose the size is 5, you can't add anything else in this, so it will just cause it to, overflow. So queues process data first in, first out, FIFO, as opposed to LIFO, which was in stacks, last in, first out. We are using first in, first out for queues. You could think of it as first come, first serve. Here we have a public class queue. We're gonna create some awesome variables. Here we have a linked list queue. We have some size. We have a final constant value int default max size. We could get the integer.max value. We could get the max size for the value of the queue if we want from the user. And then after that, we create our constructor, and it automatically gets the maximum size for an integer and stores it in it. And after that, we also create another constructor that has the maximum size passed in as an input parameter. It will initialize our linked list. Over here was just declared. It creates the object here. The size is also 0. The max size is the max size that was passed in. Since this is now being created, the constructor for the linked list will be called, and you can see that the linked list constructor is just going to be on top here where the head will be null. And now you can see that the boolean has space method will be implemented. You could just see that it has the return this dot size less than this dot max. So if the size is less than the maximum size that it supports, we could say that this thing has space, so we just return true. Another operation is the empty, just like in the stacks, we'll return if the queue is empty or not by just saying this dot size is equal to 0. If it returns 1, it's true, and then that would just be there. And queue is to add things to the end of the queue, and we'll first look at the size if it's let's say if it's a bounded queue, and we'll just say this dot queue add to tail method, which is over here, and we're just adding it to the tail, and you can see that we put in the data and then we increment the size. For instance, if the queue was full, we'll just throw an error message saying that the queue is full. After that, we have the dequeue method, and if the queue is not empty, we actually so we have to first look if the queue is having something inside, because we're gonna try to remove things, and if we don't have anything beforehand, then it's just gonna cause us problems. So that's why we throw this queue is empty error message. But in this case, if it has some value, we just get the data, so we store it in some string, and we get the queue.remove head. So since remove head over here returns a string, which is the data, we pass we get that as a return type, and we also assign it to the data value. We decrement our size and we return the data. We have the peek method, and in the peek method, we're just looking at the queue, the head of the queue. So first we're gonna check if it's empty. If it's empty, we're just gonna return null, else we're just gonna say queue.head.data. And there you go. This is our queue data structure that was implemented in Java. If you guys like this video, give this video a big thumbs up. It was pretty cool, and I hope I see you guys very soon.